Okay, this is the final lesson in Unit 2, which I think most of you will be happy about. The lesson is called Proving Lines Parallel. So first things first, I have 8 theorems / postulates here about parallel lines. Now the first 4 we've done before, well, I don't think I actually gave you the name yet, okay? So the first one, if 2 parallel lines are cut by a transversal, it has to be parallel, then the corresponding angles are congruent, okay? We did that before, but I never gave you the name. That one's called a postulate, okay? All 4 of these cannot all be called theorems because all 4 of them cannot be proven. So the way your textbook calls it and the way most textbooks call it is they call this one a postulate and they call the other 3 theorems, okay? The second one, if 2 parallel lines, again, are cut by a transversal, then the alternate interior angles are congruent. So alternate interior angles theorem. Next one, alternate interior angles are congruent again. Exterior this time, alternate exterior angles are congruent. That's the alternate exterior angles theorem. And the last one with the same side interior angles, they are going to be supplementary. So that's called the same side interior angles theorem. Okay? So all 4 of those we've done before. We did them in the first unit, but I never gave you the actual names. Those are the names. Okay? And the converse of each of them is true. Remember, the converse is when you switch around the hypothesis and the conclusion. So for the corresponding angles postulate, if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. The converse, if 2 lines are cut by a transversal so that a pair of corresponding angles are congruent, then the 2 lines are parallel. So you'll see the converse of each of them is true. So if you know the alternate interior angles are congruent, then you can conclude the lines are parallel. Or if you know the alternate exterior angles are congruent, then you can conclude the 2 lines are parallel. Or if you know the same side interior angles are supplementary, then you can conclude the 2 lines are parallel. Okay, so let's try example 1. And again, all of those 8 postulates / theorems, those are going to be, if you want to read them over, they're on Classroom, obviously, with this lesson. And I put them in that big list of all the properties and theorems and whatnot for this unit. Okay. In the figure, segment BG bisects angle ABH. Determine which lines, if any, are parallel. Okay. Let's start by looking at, I'm going to start with the bottom 2. Let's start with DF and GH. Let's start with these 2 lines. Are these 2 lines parallel? Meaning, can we figure out any of these 4 things? If we have any of these 4, then we can conclude the lines are parallel. See? So if we have any of these 4, we can conclude the lines are parallel, the bottom 4. So let's see if we can find this angle right there, angle BDF. We should be able to get that angle right away because we have a triangle, and the triangle angle sum theorem says that all the angles in a triangle always add up to 180. So if those 2 angles labeled in the triangle are 65 and 45, that means they add up to 110, which means this missing angle right here has to be 70. So let me label that as 70. Again, that one's kind of hard to see. Let me do it in a darker color. Let me do it in pen. Do that in red pen. I'm not sure how well you can see that. It's kind of small and it's on video, but that says 70 and that says 70. So since these 2 are the same, it means that we have corresponding angles that are congruent. Therefore, these 2 lines are parallel by the converse of the corresponding angles postulate. Check this out. If 2 lines are cut by a transversal so that a pair of corresponding angles are congruent, then the 2 lines are parallel. And if you look, these 2 angles, these are corresponding angles, and they're each 70 degrees. So since the corresponding angles are congruent, I can conclude that these 2 lines are parallel. So I'm going to say, I'll say DF, line DF is parallel, that's a symbol to parallel, is parallel to GH. And I'm going to say by the converse of the corresponding angles postulate. Let me just write that all down. Okay? By the converse just so you know what I'm doing, by the converse of the corresponding angles postulate. Okay, so again, the converse of the corresponding angles postulate above, it says, if two lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. And we have 70 and 70, so since the corresponding angles are congruent, it means that the two lines are parallel. So DF, line DF, is parallel to line GH. Okay. Now let's figure out if AB is parallel to those lines. So if AB is parallel to one of these lines, then it's parallel to both, because these two are parallel. If AB is not parallel to one of the lines, then it's obviously not parallel to both, because DF is parallel to GH. So let's see if AB is parallel to them or not. If you notice above, it says BG bisects angle ABH. Why are you told that? Are you told that just for no reason, or because you need it? Okay, we're going to use that. So since this angle ABH is bisected, it means this angle is congruent to this angle. So since this is 45, this angle right here is also 45. So let me label that. And so check this out. I'm looking at these two lines now, the top two lines. This 45-degree angle and that 70-degree angle, those, because that says 70, again, it's small to see online, but that says 70. Since these two angles right here are alternate interior angles, they should be congruent for the lines to be parallel. Since they are not congruent, it means the lines are not parallel, okay? They may look parallel, but we have to go by what we're given. So since these alternate interior angles are not congruent, then these two lines are not parallel, okay? So I'm going to say AB is not parallel to DF. And since it's not parallel to DF, then it's not parallel to GH, because DF and GH are parallel. So I'm going to say AB is also not parallel to GH. Okay? That problem is a little tricky. That's how it works. So again, you need to know these 8. You should know those 8 above. The first 4 we did already in the first unit, so I think most people know them. Now you just have the name, and the bottom 4 is the converse. And even though you have this sheet for reference, if you memorize them, it will be easier going forward for you. Okay. Example 2. Find x in the measure of angle RSU so that M is parallel to N. Okay. Well, the two angles labeled, those are corresponding angles. If they are congruent, then M is parallel to N. So if these two are congruent, because they're corresponding angles, then that means that M is parallel to N. So the x value that makes them parallel is the x value you get when you set them equal to each other and solve. So I'll do 9x minus 11 equals 8x plus 4. And I'll solve that for x. So subtract 8x on each side. X minus 11 equals 4. Add 11 to each side, and you get x equals 15. And now let's find the measure of angle RSU. So the measure of angle RSU equals 8x plus 4. Substitute 8 times 15 plus 4. Okay. 8 times 15 is 120, plus 4 is 124 degrees. Now let's double check that, just to be positive that we're right. Let's test 9 times x. If you do 9 times x plus 4, minus 11, 9 times x, 9 times 15 is 135, minus 11, because it's minus 11, equals 124. So this also equals 124. It should be the same as that, and it is. So that means I know I got it right just by double checking that. Okay. Example 3, determine whether F is parallel to G. Okay. Well, parallel lines have the same slope. I'm not sure if you remember that from Algebra 1. I don't think we've talked about that in this class yet. Parallel lines have the same slope. Okay? That's what you need to know. And here's our slope formula. y2 minus y1 divided by x2 minus x1. So let's start with the slope of f, and then we'll do the slope of g. If the slopes are the same, then the answer is yes, they are parallel. If the slopes are not the same, then the answer is no, they are not parallel. So I'll say slope of f. y2 minus y1. So I'll do 4 minus 0. Again, we're looking at line F, 4 minus 0. Subtract the y's, divide by, subtract the x's, 6 minus 3. So when you simplify that, you get 4/3. And now let's do the slope of line G, and let's see what we get. If the slopes are the same, the answer is yes. If the slopes are different, the answer is no. So for G, subtract the y's, so 4 minus 0 divided by 0 minus negative 3. Okay. 4 minus 0 divided by 0 minus negative 3. When you subtract the negative, that's the same as plus a positive. So this equals 4 over 3. So for my final answer, I'll put it down here. The slopes are the same, so the answer is yes. So I'm going to say since the slopes are the same, I'll say F is parallel to G. That'll be my answer. Okay. One more page, and that's it for this lesson and for this entire unit. So yay. Okay. We got some proofs. Oh boy. You didn't think you were getting off that easy, did you? We're doing just 2 proofs today in this lesson. Okay. So here we go. Given G is parallel to H, so you can see that's labeled, and angle 1 is congruent to angle 2. I'll just label that. Oops. Oh well. Smudge. I'll label angle 1 being congruent to angle 2 like that. That's going to annoy me, that smudge. So let me wipe that out really quick. I think I need to get a new pen now. I'll power through. Okay. So I labeled angle 1 being congruent to angle 2 because we're told that in the givens. So let's do reason 1. Let's fill them both in. Reason 1's given, of course. And let's fill in statement 1. G is parallel to H. And angle 1 is congruent to angle 2. Now, in case you're wondering, well, let's see. It says use the symmetric property of congruence next. So the reason why we're doing that, you'll see in a minute, but I'm going to say angle 2 is congruent to angle 1. I'll explain why we're doing that in a minute. Symmetric property of congruence. We had angle 1 is congruent to angle 2. I just rewrote that as angle 2 is congruent to angle 1. Now, check out angle 1 and angle 3. 1 and 3 are corresponding angles, and you know that corresponding angles are congruent. So I'm going to say angle 1 is congruent to angle 3. What is that reason? Well, let's go back to the first page and look at it. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. So that's called the corresponding angles postulate from the first page of these notes. Okay? So I'm going to say corresponding angles postulate. Okay. Now, and the reason why I use the symmetric property of congruence in step 2 is because now we can use the transitive property of congruence. Look, angle 2 is congruent to angle 1, and angle 1 is congruent to angle 3, so angle 2 is congruent to angle 3. Okay? And that reason is called the transitive property of congruence. So let me label that. Since angle 2 has one arc, I'll put one arc in angle 3. Now, you may be wondering, why can't you just say that 2 is congruent to 3 because they're alternate exterior angles? Think about that for a minute before I tell you the answer. Why can't you just say 2 is congruent to 3 right away? Because they're alternate exterior angles? The reason is because you don't know P is parallel to R. You don't know if those two are parallel. That's why you can't say 2 is congruent to 3 right away. But anyway, now we have angle 2 is congruent to angle 3. So now you can say P is parallel to R. Why can you say that? Look back at the first page. We are doing the converse of the alternate exterior angles theorem. If two lines are cut by a transversal so that a pair of alternate exterior angles are congruent, then the two lines are parallel. That's what we had. Okay? We have the alternate exterior angles congruent, so we can say the lines are parallel. So converse of the alternate exterior angles theorem. Okay. All right, let's try this next one. Got a little smudge from my pen over there, though. Okay. Let's start with the givens. We have N is parallel to M, and that's labeled. And we know that angle 1 is congruent to angle 2. So I'll label that in the diagram. 1 is congruent to 2. That's it. So that was given. Then it says use the symmetric property of congruence for step 2. So I'm going to say angle 2 is congruent to angle 1. All right. Now, let's look at angle 1 and angle 3. Those are, so that's 1, and that's 3. 1 and 3, those are going to be congruent because those are alternate interior angles. So I'll say angle 1 is congruent to angle 3. And again, if you want to know why, I'll just flip back to the first page. That is the alternate interior angles theorem. Okay. Now, and again, the reason why I use the symmetric property in step 2 is because now we can use the transitive property with these 2 steps. I can say angle 2 is congruent to angle 3, transitive property of congruence. And again, the reason why you can't say 2 and 3 are congruent right away, even though they look like alternate interior angles, and they are, as the lights go out in my room, even though they look like alternate interior angles, and they are, but you don't know P is parallel to R. So since you don't know P is parallel to R, you cannot say that the alternate interior angles are congruent. Okay? You have to be told the lines are parallel to say that. But now I can get to my conclusion, what I had to prove. I had to prove that P is parallel to R, and I did. If you go back to the first page, I used, let's see, I used this one right here, the converse of the alternate interior angles theorem. If 2 lines cut by transversal so that a pair of alternate interior angles are congruent, then the 2 lines are parallel. And that's what we have now. We have 2 and 3 being alternate interior angles, and we have them congruent. So I can say the lines are parallel. So I'm going to say that's the converse of the alternate interior angles theorem. Okay, so that is the end of that lesson, proving lines parallel, and that is the end of this unit, logic and proof. So everybody go celebrate right now.